Welcome to challenge number 70. We have a spatial challenge this time. So the idea is we're supplied for three office locations. We aim to find somewhere that's equal distance from each other. It's pretty much like triangulation. So that's how the mobile phone or GPS basically used to determine the locations. They do asking for the drive time. We don't have the drive time package. So this stay here. Ooh, choose that. So 30 minutes drive time. We don't have it. So instead, we're going to just pick some kind of arbitrary distance to say, okay, anything within that. The geometry logic of it, it's like a diagram. Do the first circle, you draw a net. You draw a second circle, your trade area. Then you're looking for hopefully the third, anything in between, the overlapping of all three areas is the thing you will be more interested. Now, for each of us, let's change it to green. So that's will be a center point. That will be center point. That will be a center point. Because at the moment we're looking for 30 miles, that's what I assume you're going to have an equal radius for the things. Then the final distance in the middle, let's use a different color. Great. That's equal distance to all three things. But they're not looking for that spot. They're looking for purely just for the area, the final answer. So you can see the final area is equal distance. That is square miles. Otherwise, you're looking for the intersection between the points. That's it. The first thing, we have a large long, so it's making points. Spatial grade points. We have a site num ID, that's good. That makes things easy to keep track of. The next trade area. Because in the city, we have different training, so I think I used 10. I'm going to use 10 kilometers as on the trade area. So create those different circles. 30 minutes drive. If you drive in UK, if you drive is 70 kilometers, 70 miles, 35 miles should be your area. Actually, it's better to be safe. Let's go at the browse tool just to see those circles. How are they catching each other? Are they like intersect each other, or they are totally not? Because sometimes if you really have too big of circle at 1,000 miles, then those three circles almost overlaps. That's good. So if we use a 10 kilometers radius, we have no intersection between those three. In that case, I think we can just change it to now. I won't stick with kilometers. I'm going 15 kilometers. Hmm. If you look at the random map, they should probably overlap now. Yeah, we have some kind of overlapping area of the things. So probably somewhere here in the center, those kind of overlapping. If you're overlapping, you can kind of safe to assume up to some rounding area, they're reasonably close to all 3 points. That's the only common radius distance apart. So we're going to stick with 15 for now. Next, let's not select it. Let's do pairwise of intersections. So the first pair, we care the spatial match process. We try to do Venn diagram. So to do that spatial match, I think it's a spatial process. Spatial process has only one input, so you cannot say left data source, right data source. That means we need to pivot our data. We need long to wide format. So cross tab. How do you want to head that? Site. I do want to use the site as like a record ID. Yeah, I'm gonna probably stick with city as the record ID. Site should be the headers now. So where's my site? Yeah, so site is on top. the information, the value for the column is the special object, the trade area we care about. Excuse me. Let's pivot. Oh, I forgot to select the last one, concatenate. Oh no, it's a spatial object, so the option is first. We don't have multi-rows, so we don't need to worry about that. 1, 2, 3, that's a three object. Then we can do the spatial process. We're looking for 1 and 2, we're looking for the middle common points, so that's about finding the intersection between those things. So run the stuff. Efficiently. Because it's spatial, it's always good to have a browser to be able to visualize each step to make sure we're on the right track. So object 3 we don't care about yet. Let's just visualize spatial 1, spatial 2. If we remove 1 and 2, then you'll be able to see on the map here, that's an overlapping area. So it's kind of like oval-ish shape. That's good. Then we're gonna rinse and repeat to have another spatial process. So I think the next thing we'll basically do, not that one, we'll probably just do a cuts with circle 3. So this time we're gonna do spatial process 3 against the previous spatial process. We're gonna continue to do the output. Let me see, select. We can probably keep it select. The final answer they're looking for is how much an area. So let's throw. We're looking for the final spatial process 2. We're looking for area. We use the kilometer as a radius. Let's take kilometer as a measurement. We can also add a browser. Should be fine. You can add either one. Let's run the workflow. If we remove the object, 1, 2, 3, the base circle. Let's zoom in a bit. So as you can see, the overall shape is what you have. The inner part, the little triangle here, that's the overlapping part with the spatial object 3. So the third office trade area. Within this area, it's technically you should look for the center of the area, but for us, given the size, we find this is the almost equal distance between this point to all other points. Yeah, actually, so the answer we get is probably 1.9697. Since we're here, let's actually learn a little bit more about spatial tool. Among them, we have an option to have centroid of the object. So presumably, hopefully, that will give you the center point. Let's run this process again. We can actually calculate the distance between the centroid and things. Rather than do formula one by one, I'm going to pivot long again. So this is outside the scope of this challenge. Let's good practice. What do I want? I want to pivot to 1, 2, 3. The one I want to hold the group against is a centroid. It's not necessarily the best practice to group by those long field, but ideally you want a string field. So I can do my formula. My centroid should be, hopefully, the center point for the spatial match, the Venn diagram, the inner intersections. Distance, we can make st distance. So the object we're looking for centroid towards the values. So those are the original office locations. km, because we use a 15 kilometer as, yeah, so we can probably km is fine. That's a double. Ooh, I'm a little bit suspicious. Why is the 4142 looks massive? Kilometers. Ooh, meters. Value units, they only accept km. Okay, on top you get 43. Impulse value, have a look on this. Yes, noted in my issue. I got the wrong value. User value shouldn't be polygon. Shouldn't be polygon. Should be the centroid from the previous step. So let's select the correct field to pivot. Let's see. Oh no, I dropped my centroid, isn't it? Okay, that's annoying. Let's do append instead. So you want append? Starting data source, I'm going back to the very starting, my centroid. Set centroid is fine. I want to join with my right. So the right, I deselect everything. I only need is the right centroid. Centroid. So that's a site. That's center for that. In this case, I don't need a formula. I can just use probably a distance tool to do the calculations. Centroid against the center, distance, distance. We don't care directions. Kilometers is fine. Let's just run the workflow. Yeah, so reasonably close, 40.4, 40.3. So the centroid for the single point probably fluctuate a bit because maybe to do with the final intersection point is not necessarily of regular shape. Mm, I'm not sure. I feel like that should be regular shape. But overall, it's reasonably close up to some decimal places. Presumably, we narrow things down to a better different radius circle. We can narrow down the centroid to be more accurate on things. So yeah, so that's kind of like GPS location. You can see, oh, how accurate given the transmissions to determine a person. So you can see within the plus minus 10 meters was within plus minus 100 meters of distance. And that is the challenge number 70. Thanks for watching.